Hi guys, this is Dr. Niaz Muhammad. In this lecture, I shall discuss some basic concepts of chemistry. So let's start with its definition. Chemistry is the study of matter, and matter is something that has mass and volume. For example, a pen we use for writing, the water we drink, the air we breathe, and common salt or sodium chloride that we use to make our food delicious are some common examples of matter. Now, matter exists in three different states, that is solid, liquid, and gas. For example, the pen is a solid substance, water is a liquid matter, and air is an example of gaseous matter. This matter is made up of small particles. These small particles are called atoms. Now, let's discuss some more points about this atom, which is the building block of matter. An atom has two parts. The central, relatively denser or somewhat compact part is called nucleus. Inside nucleus, we have different particles. The particles present inside the nucleus, they are called nucleons. Two most important nucleons are called protons and neutrons. The protons are positively charged particles. Their relative charge is +1, while neutrons are neutral particles. They don't carry any charge. The relative mass of a proton is 1.0073 AMU, or simply it's taken 1 AMU. Remember, 1 AMU is always equal to 1.673 into 10 to the power minus 27 kg. Similarly, the relative mass of 1 neutron is 1.0087 AMU. Again, it's simply taken as 1 AMU, but remember, a neutron is slightly heavier than a proton. Now, the number of protons present in the nucleus of an atom is always called atomic number. For example, if I say the atomic number of sodium is 11, it means there are 11 protons in the nucleus of sodium atom. Similarly, the atomic number of carbon is 6, means there are 6 protons in the nucleus of carbon atom. Similarly, the sum of protons plus neutrons present in the nucleus of an atom is called atomic mass or mass number or Nucleon number. For example, the atomic mass of sodium is 23, means the sum of protons and neutrons present in the nucleus of sodium is equal to 23. Now, around the nucleus, the outer part of atom largely consists of empty space, and in this empty space, third type of particles called electrons are present in specified regions. These specified regions are called shells, orbits, or energy levels. For the placement of electrons in these shells, we use the formula 2n square, where n represents number of shell. For example, in first shell, according to this formula, we can place 2 electrons. In the second shell, according to this formula, we can place 8 electrons. And by using this formula, we can place 18 electrons in the third shell. But remember, up to atomic number 20, we normally keep only 8 electrons in the third shell. Now, the mass of an electron is 0.0055 AMU, or simply this mass is considered as 0 AMU. So it means the mass of an atom is due to the mass of protons and neutrons present in the nucleus. The relative charge of each electron is -1. Now, these three types of particles which are present in an atom, that is proton, neutron and electrons, they are also called subatomic particles. Now, remember, an atom is electrically neutral. It means the number of positively charged protons in the nucleus is always equal to the number of negatively charged electrons present in the shell. For example, sodium has 11 protons in the nucleus and 11 electrons which are placed in the three shells. The positively charged protons cancel the effect of negatively charged electrons, so there is no net charge on sodium atom. An atom is always represented by a proper symbol. For example, for hydrogen the symbol is H, for helium the symbol is He, also for calcium the symbol is Ca, for chlorine Cl is used, and for chromium the symbol Cr is used. It means when different atoms start with same letter, then a two letters symbol is used for the differentiation. The first letter is always capital while the second letter is small, as you can see over here in these examples. The atomic number of an atom is written at left top of the atomic symbol, while atomic mass is written at left bottom of the atomic symbol. For example, in case of sodium, the number 11 present at left top of the symbol shows its atomic number, while number 23 written at the left bottom of the symbol shows atomic mass of sodium. Now let's see how can we find the number of protons, neutrons, electrons and electronic configuration or placement of electrons in different shells of an atom. Let's take example of sodium atom. The symbol for sodium is Na. Its atomic number is 11 and its atomic mass is 23. A's atomic number shows number of protons. So there are 11 protons in an atom of sodium. Also, atomic mass is the sum of protons and neutrons. So number of neutrons is equal to atomic mass minus atomic number. Here for sodium it is 23 minus 11 equal to 12. So there are 12 neutrons in the nucleus of sodium atom. As I said earlier, for a neutral atom, the number of protons are equal to the number of electrons. So sodium has 11 electrons. These 11 electrons are placed in three shells. In the first shell, 2 electrons are present. In the second shell, 8 electrons are present, while 1 electron is present in the third shell, that is also called the valence or last shell of sodium. Now let's find protons, neutrons and electronic configuration of calcium atom. An atom of calcium has 20 protons as its atomic number is 20. The atomic mass of calcium is 40. So the number of neutrons are 40 minus 20 equal to 20. Electrons in an atom of calcium are also 20. The electronic configuration of calcium shall be 2, 8, 8 and 2. Remember, up to atomic number 20, only 8 electrons are kept in the third shell and not 18 electrons. Another example, let's find number of protons, neutrons, electrons and electronic configuration for phosphorus atom. The atomic number of phosphorus is 15, so it has 15 protons in the nucleus. Its atomic mass is 31, so the number of neutrons are equal to 31 minus 15 equal to 16 neutrons. Also electrons are 15 and electronic configuration shall be 2, 8, 5. Means 2 electrons in the first shell, 8 electrons in the second shell and 5 electrons in the third or last shell. So in summary we can say for an atom, the atomic number is equal to number of protons. If the atom is neutral, then protons are equal to electrons. And for finding the number of neutrons, we subtract atomic number from atomic mass. Now as I said earlier, an atom is electrically neutral, means its protons and electrons are always equal. This neutral atom may or may not exist independently or freely. If the last shell of an atom is complete, then it is stable and it can exist independently. However, if the last shell or valence shell of an atom is incomplete, then the atom is unstable and it can't exist independently. Let's see some examples. Compare the atoms of hydrogen and helium. Helium has 2 electrons in its last shell. As the valence shell is complete, so helium atom is stable and it can exist as such in atomic form. Now if we see an atom of hydrogen, it has only 1 electron in its valence shell, so it is unstable and can't exist in atomic form. Another example, see an atom of neon. Its atomic number is 10. It has 10 electrons. So 2 electrons are kept in the first shell and 8 electrons in the second shell or valence shell. Now as the valence shell is complete, so neon atom is stable and can exist independently. Now if we see an atom of fluorine with atomic number 9 and electronic configuration 27, we can say fluorine is unstable due to incomplete valence or last shell. Also, an atom of sodium is unstable as its electronic configuration is 281. The last shell of sodium is incomplete, so it can't exist freely. Now, for achieving stability, an atom can lose or gain electrons. And after this loss or gain of electrons, the last or valence shell of an atom becomes complete and it becomes stable. Remember, after this loss or gain of electron, an atom becomes a charged particle and this charged particle is called an ion. Now, if an atom loses electron, it becomes positively charged ion or called cation, and if an atom gains electron, it becomes negatively charged ion or called anion. Let's see some examples of positively charged ions or cations. We have sodium atom with atomic number 11 and electronic configuration 281. As the last shell of sodium is incomplete, so it is unstable. For stability, an atom of sodium can lose its last shell electron. After the loss of this last shell electron, only 10 electrons remain in an atom of sodium. Its configuration becomes 28. Now you see the second shell becomes the last or valence shell that is complete. So sodium becomes stable. As there are still 11 protons in the nucleus of sodium and just 10 electrons in the two shells of sodium, so 11 protons minus 10 electrons is equal to +1 charge of sodium. Now as sodium carry a +1 charge, so it is a cation. Remember, the positively charged sodium ion has smaller size than neutral sodium atom. In a neutral sodium atom, 3 shells of electrons are present, while in sodium ion, 2 shells of electrons are present. That's why sodium ion has smaller size. Also, when sodium loses electron, the remaining 10 electrons are attracted by the nucleus more effectively, that shrinks the size of sodium ion. Let's see another example. A magnesium atom with atomic number 12 has electronic configuration 2A2. This magnesium atom loses 2 electrons from its last shell and becomes stable with electronic configuration 2A8 and carries a charge of 2+. Also, aluminium with atomic number 13 and electronic configuration 283 is unstable. However, after the loss of 3 electrons from the last shell, aluminium carries 3+ charge and becomes stable with electronic configuration 2,8. Remember, the number of electrons lost from the last shell of an atom appears as a positive charge on an atom. As we saw, sodium carries 1+ charge due to loss of 1 electron. Magnesium carries 2+ charge due to loss of 2 electrons, and aluminium carries 3+ charge due to the loss of 3 electrons. These 3 cations we discussed here, that is sodium 1+, magnesium 2+, and aluminium 3+, have same number of electrons. You see, all of them have 10 electrons. These ions having same number of electrons are called isoelectronic ions. Remember, in case of isoelectronic positive ions or cations, as magnitude of positive charge increases, then size of the ion decreases. So we can say aluminium 3+ has a smaller size than magnesium 2+ ion, and a magnesium 2 plus ion has a smaller size than sodium 1 plus ion. The reason is all these three ions have 10 electrons arranged in two shells, 2 electrons in the first shell and 8 electrons in the second shell. The nucleus of aluminium 3 plus ion has 13 protons, which can attract the 10 electrons more effectively compared to the 12 protons of magnesium 2 plus ion or 11 protons of sodium 1 plus ion. As a result of this, the size of aluminium 3 plus ion is smaller than magnesium 2 plus ion and sodium 1 plus ion. Similarly, the size of magnesium 2 plus ion is smaller than the size of sodium 1 plus ion. Now, let's see some examples of negatively charged ions or anions. We have fluorine atoms with atomic number 9 and electronic configuration 2, 7. As the last shell of fluorine is incomplete, so it is unstable and can't exist independently. For stability, an atom of fluorine gains 1 electron. After gaining 1 electron, the electronic configuration becomes 2, 8 for fluorine and it carries 1 minus charge. Protons are still 9 in an atom of fluorine while electrons become 10. So 9 protons minus 10 electrons becomes equal to minus 1 charge of fluoride ion. Now remember, the negative ion has always larger size than its neutral atom. For example, fluoride ion has larger size than neutral fluorine atom. The reason is, after gaining an electron, the inter-electronic repulsion increases in fluoride ion that expands its size. Now let's see another example of negatively charged ion or anion. An atom of oxygen with atomic number 8 and electronic configuration 2, 6 is unstable. To complete the valence shell, an atom of oxygen gains 2 electrons. Its configuration becomes 2, 8. The last shell becomes complete and oxygen carries 2 minus charge. Also, nitrogen with atomic number 7 and electronic configuration 2, 5 gains 3 electrons to complete its last shell. The configuration of nitrogen atom after gaining 3 electrons become 2, 8 and it carries 3 minus charge. So you see, when an atom gains electrons, it forms negative ion or anion. Also, the number of electrons gained appear as negative charge on an atom. As you can see, fluorine gains 1 electron and carries 1 minus charge. Oxygen gains 2 electrons and carries 2 minus charge. And nitrogen gains 3 electrons and carries 3 minus charge. Now, all these 3 anions, that is F1 minus, O2 minus and N3 minus, have same number of electrons. Each of them have 10 electrons, so they are also called isoelectronic ions. Remember, in case of isoelectronic anions, as magnitude of the negative charge increases, size of the ion also increases. We can say N3 minus ion has larger size than O2 minus ion and O2 minus ion has larger size than F1 minus ion. Remember, electrons repel each other. Nitrogen gains 3 electrons, so experience more inter-electronic repulsion, and as a result size of N3 minus ion is larger than O2 minus ion, that is formed by the gain of 2 electrons. Similarly, the inter-electronic repulsion is more in O2 minus ion compared to F1 minus ion, that is formed by the gain of 1 electron. The difference in sizes of N3 minus, O2 minus and F1 minus ions can also be explained in form of different number of protons present in the nucleus of these ions. All these ions have same electrons but different number of protons. N3 minus ion has 7 protons, O2 minus ion has 8 protons and F1 minus ion has 9 protons. In case of N3 minus ion, the attraction of 7 protons for 10 electrons is weaker, so size is larger. The 8 protons of O2 minus ion attracts its 10 electrons more effectively than N3 minus ion, so size of O2 minus ion is smaller than N3 minus ion. And 9 protons present in the nucleus of F1 minus ion even attract the 10 electrons more strongly compared to N3 minus ion and O2 minus ion. So fluoride or F1 minus ion has smaller size than N3 minus and O2 minus ions. So in summary, we can say N3 minus ion has larger size than O2 minus ion, and O2 minus ion has larger size than F1 minus ion. Now, how to find number of protons, neutrons, electrons and electronic configuration for cations and anions. Let's see some examples. First, for sodium 1 plus ion. Its atomic number is 11, so protons are 11. For number of neutrons, we subtract atomic number from atomic mass, that is 23 minus 11 equal to 12 neutrons in the sodium 1 plus ion. To find number of electrons, we know number of protons are equal to number of electrons. However, in case of positive ions, the number of electrons are equal to atomic number minus charge of the positive ion. So in case of sodium 1 plus ion, atomic number is 11. Charge is 1 plus, so 11 minus 1 is equal to 10 electrons, and the electronic configuration is 2, 8. So there are 11 protons and 12 neutrons in the nucleus of sodium 1 plus ion and 10 electrons placed in 2 shells. Let's see another example of calcium 2 plus ion. The atomic number of calcium is 20 and atomic mass is 40. There are 20 protons as atomic number of calcium is 20. For neutrons, the atomic number is subtracted from its atomic mass. So 40 minus 20 is equal to 20 neutrons. The charge on calcium ion is 2 plus. So to find number of electrons, we shall subtract 2 from atomic number. That is 20 minus 2 equal to 18 electrons. And now electronic configuration is 2, 8, 8. So there are 20 protons, 20 neutrons in the nucleus of a calcium 2 plus ion, and 18 electrons present in the 3 shells. Now let's see examples of some negative ions. First, phosphorus 3 minus. Atomic number of phosphorus is 15 and atomic mass is 31. So there are 15 protons in the nucleus of phosphorus. For neutrons, again atomic mass minus atomic number, that is 31 minus 15 equal to 16 neutrons. Now as we know, negative ions are formed by gain of electrons. So in case of negative ions, to find number of electrons, we simply add number of electrons gained to the atomic number. That is for P3 minus ion, the number of electrons are 15 plus 3 equal to 18 electrons. And the electronic configuration is 288. Another example of sulfide ion, that is S2 minus. Atomic number of sulfur is 16 and atomic mass is 32. Now number of protons are 16. Number of neutrons are atomic mass minus atomic number are 32 minus 16 equal to 16 neutrons. Now to find electrons, we know atomic number of sulfur is 16 and 2 electrons are gained as shown by 2 minus charge on sulfur. So 16 plus 2 makes 18 electrons in a sulfide ion. The electronic configuration of S2 minus ion is 288, means electrons are arranged in 3 shells. Now guys, at the end, let's have a brief summary of this lecture. Chemistry is the study of matter. Matter is something that has mass and volume. Matter exists in 3 different states, that is solid, liquid and gas. Matter is made up of small particles called atoms. An atom has 2 parts. The central part or nucleus has protons and neutrons, while the outer part of atom has electrons in shells. Protons are positively charged particles, electrons are negatively charged particles, and neutrons are neutral in nature. The relative mass of proton is 1 AMU. The relative mass of neutron is also 1 AMU, while the mass of electron is negligible or considered 0. Number of protons is called atomic number, and the sum of protons plus neutrons is called atomic mass. An atom is electrically neutral because number of protons is equal to number of electrons. An atom is represented by a symbol. An atom may or may not exist free in nature. When an atom loses electron, it forms positive ion or cation. When an atom gains electron, it forms negative ion or anion. Ions having equal number of electrons are called isoelectronic ions. Now guys, for the self-assessment, you can solve this small test on your own. And thank you so much for watching this lecture. See you next time with some more basic chemistry concepts.